Okay, we look at stationary points. We know that stationary points, there are three types of stationary points. The first is a maximum point, or this maximum point. The second is a minimum point. And the third type is a point of inflection. So these are the three types of stationary points that we are dealing with. And the characteristic of stationary point, basically these two, we call them turning points. Alright? That means at this point where it turns, and at this point of inflection, there is a common trend. If we draw a tangent to these points, the tangent would be a horizontal line. In fact, let me rephrase. This doesn't look very, point of inflection doesn't look very good. It actually is more like that. Okay. Now, so for all these stationary points, the tangent is a horizontal line, meaning the gradient of all these points, the gradient of the curve at these stationary points must be equal to 0. So this is what we already learned earlier. The gradient is 0. But now I'm going to introduce this second derivative. So what we learned earlier is the first derivative. You differentiate y with respect to x once. Now if I differentiate a second time, the way I write it is d2y by dx square. This is known as the second derivative. So what is so significant about this? Here, I'm going to explain it using this. Now we look at the first stationary point, the maximum point. The gradient of this maximum point. Imagine if you start from the left side. The gradient here is the orange line. It's positive, right?
No.
Then it goes up. As it reaches the stationary point, as it reaches the maximum turning point, its gradient is getting less and less steep, but they're all positive gradient. Then you reach a plateau at the peak, at the turning point, the gradient is 0. And you move to the right side, it goes this way. The gradient becomes like that. Now can you tell me the green line, the tangent, what is the gradient of this green line?
Negative.
So it becomes negative. So the gradient of a maximum point as x increases, as you move from left to right, the gradient of a maximum point changes from very steep positive to gentler and gentler to become 0 gradient, and then becomes negative and more negative and even steeper negative. So for maximum point, can you describe to me the second derivative? The gradient is actually increasing or decreasing from positive to negative, from a big number to a small number. The gradient is decreasing, right? That means if I plot, let's just say, a graph of dy dx by x, the gradient is actually decreasing. Agree now? this value, this dy dx is getting smaller and smaller. In fact, it is getting smaller and smaller until it reaches negative. Can you see? So this kind of graph, the gradient of this graph is actually d2y by dx squared. Because you are differentiating dy dx with respect to x. So it's d2y dx squared, the second derivative. And this gradient of this graph is actually negative. So if I may add, for a maximum curve, d2y dx squared is actually negative value. Are you following? Now we look at the minimum point. The gradient of the tangent is actually negative. This is a negative value, and it's getting gentler and gentler, and it moves to the next section, which is positive. So this is a positive gradient, getting more and more steep. So if we come back to our argument earlier, we plot a graph of dy dx against x for minimum point is moving from negative to positive. Agree or not? Okay, whether it's a straight line or not is immaterial. That's not our focus. But we know that it moves from a negative region. This part here is all negative. This part here is all positive. Positive dy dx and negative dy dx. So we know that it has moved from negative dy dx to positive dy dx. Now the gradient of this graph again is d2y by dx squared. And this, you tell me, is it positive or negative?
Positive.
It's positive. So for a minimum point, d2y by dx squared is actually a positive value. The third one, the point of inflection. Think aloud. The left hand side. Just like that. Like that. Like that. What kind of gradient is this? The orange
Positive.
line. Positive, positive, positive. And then the other side.
Positive.
It's also positive, right? Positive, positive, positive. So it's getting from steep positive to gentle positive, and then from gentle positive to steep positive again. So based on this, let's look at the profile of the gradient changing. It's changing from very positive to less positive. So it could be a case of like that until it reaches 0. Huh? This middle point here, the gradient is
0.
So it reaches 0, and then it goes back to positive again. So I refrain from using a straight line for this case, so that I will avoid a sharp turn at this point. So at this point, dy dx is 0. What can you say about about the gradient d2y dx squared? At this point, we are looking at the point of inflection. So this is the point of inflection. So what's the gradient at this point?
0.
Yes, it goes to 0. Similarly, at this earlier one, the gradient, so this is the minimum point, and this one, this point here, this is the maximum point. So for point of inflection, the second derivative is equal to 0. Got it?
Yeah.
Now we look at this example. Equation of the curve is y equals to 2x squared over x minus 1. Find the expression for dy dx and obtain the coordinate of the stationary point of the curve. Okay, do the first one. Dy dx. Quotient rule. Come. Let's try. Differentiate the top first or the bottom first?
The top.
So differentiate the top.
4x.
4x, very good. And then you keep
The bottom.
the denominator, x minus 1. And then this
Minus.
minus, very good.
Then x.
X. Now you're differentiating the bottom or the top.
Bottom.
And you are keeping the
top.
So the top, keep it, don't change. And then differentiate the denominator. What do you get?
X. 1.
What? Yes. And here, divide by?
Divide by x minus 1 square.
Very good. So this is the expression for dy dx, which is what you need. Find expression. And obtain the coordinates of the stationary point of the curve. So obtain the coordinates of the stationary points. What do you know about the stationary points?
Is 0.
What is 0?
Like it has to be equals to 0.
What is it supposed
dy over dx is
dy
d0.
dx is 0. Correct. So let's equate this to 0. And we know the denominator cannot be 0, so the numerator has to be 0. So therefore, 4x x minus 1 minus 2x squared times 1 is equals to 0. And we expand out 4x squared
Minus 4x.
minus 4x
Minus 2x
minus
square.
2x squared equals to 0. So we have
2x square.
2x squared minus 4x equal to 0. Factorize.
2x minus 4. X minus 2.
Therefore x is equals to 0 or
Negative 2. X equals to 0 or 2.
So the coordinates of the stationary points, x is 0 and x is 2 are both stationary points. But they are not coordinates. It's just one part of the half of the coordinate.
You have to
so you have to
find
find y, yes. So you substitute x equals to 0 and x equals to 2 back into the equation to find y. When x is 0, you have 0. When x is 2, you have 2 times 2, 4, 4, 4, 4 times 2, 8. 8 divided by 1, 8. So the coordinates are
0, 0 and 2, 8.
Part 2. Find an expression d2y dx squared, hence determine the nature of the stationary points. So d2y dx squared means you have to
Square it.
square. This is not squaring. What are you doing? You're differentiating what? The first derivative.
Yeah.
So you're differentiating this thing. So you're differentiating the first derivative. So let's just write it out. So you have 4x squared minus 4x minus 2x squared. Correct?
Yeah. Minus 6x square.
No. Then it's divided by x minus 1 square. So it's actually simplified is 2x square minus 4x over x minus 1 square. Now, differentiate numerator first. What do you get?
4x minus 4.
Yes. You actually swallowed the the minus 4. And then you keep the denominator.
and then minus 1. And then keep the top over x minus 1 to the power of 4.
So the question, you got the expression already, did the first part. Hence determine the nature of these stationary points. Now you have the coordinates. You have to find the nature of these stationary points, means you have to find the nature of these coordinates. Now the curve, the nature of the curve at these 2 points. So d2y dx squared will give you information about the nature. Recall, the nature is actually asking whether is it a maximum point, a minimum point, or is it a point of inflection. So the second derivative, if you get negative, it's a maximum point. If you get positive, it's a minimum point. If you get 0, it's a point of inflection. Now, how do you determine?
Sub in the x coordinate.
So when x is equals to 0, d2y dx squared equals, you put 0, 0, everything 0 in 0, you get negative 4, negative 1 square. This one whole thing will be 0. Divided by 0 minus 1 is negative 1, 4. So that gives you is it?
Yeah.
And now when x is 2, 8 minus 4 is 4. 2 minus 1 is 2. Minus 2. 2 square 4. 4, 8. 8, 8 minus 8 is 0. So
0.
everything is still 0. Divided by 2 minus 1 is 1. So this is positive 4. 4. So if it's negative, what can you say? The nature of this curve when x is 0.
Minimum point.
Second derivative is negative.
So if its maximum point is will be negative.
d2y dx squared is negative, as I explained over here. Huh? So this one would be a
Max
maximum
point.
The next one?
Minimum point.
Yeah. The nature of the curve when x is 2 is a minimum point.